In this problem, we're given 3 lines, and those 3 lines are going to enclose a triangular region. And so what we want to do is we want to find the area of that region. So let's take the time and graph this out. So our first line is 4x minus 2. Our second line is negative 4x plus 14. Our third line is 4/3 x minus 2. So I'm going to scale out my y-axis to go from negative 2 all the way up to 14. 8, 9, 10, 11, 12, 13, 14. All right. And let's see, 1, 2, 3, 4, 5, 6. Hopefully we don't need to go any further than 6 on the x-axis, but we'll see. So the first line is 4x minus 2. So we start with a y-intercept of negative 2. Now our slope is 4, so we go over 1 and up 4. We go over 1 and up 4 more. We go over 1 and up 4 more. 1, 2, 3. Oops, should be right. 2, 6, 10, not there. And then up 4 more to 14. So there's our line. This is 4x minus 2. Our second line, negative 4x plus 14. So this one starts up at positive 14 for the y-intercept, and we go down 4, 1, 2, 3, 4, and over 1. We go down 4, 1, 2, 3, 4, over 1. And actually, I think the way this is scaled, we go from a y value of 14 to a y value of 10 to a y value of 6. So actually, this should be over there. And then we go down 1, 2, 3, 4, over 3, 4, down there. So this is negative 4x plus 14. And I want to make it a point to label this spot where they intersect, 2, 6. Now the last line is 4/3 x minus 2. So we start at negative 2, and we go over 4, 1, 2, 3, 4, and up 3. 1, 2, 3. All right. Whoops, no, did that incorrectly. I should have gone over 3. I apologize. 1, 2, 3, and up 4. 1, 2, 3, 4 to there. And so this point is 3, 2. So what we're interested in is we are interested in finding the area of this region. Now this problem is set up in such a way that using the geometric formula 1/2 base times height is very difficult. So here's how you go about this problem. What you do is you draw a box around this triangle so that the 3 vertices of the triangle touch either the corners or the sides of the box. Now this box has a width of 1, 2, 3, and it has a height of 1, 2, 3, 4, 5, 6, 7, 8, 9. Nope, that should be 8 because we go from negative 2 to 6. I miscounted that. So this box has a total area of 24. Now, within that box is this area that we want. Now, what we have to do is, instead of finding the area directly, what we're going to do is we're going to take away the area of the regions we don't want. So let's look at this. This is a triangle. So we can find this area and subtract it away from 24. This triangle has a base of 3. This triangle has a height of 4. So 3 times 4 is 12, but it's a triangle, so you have to multiply by 1/2. So this triangle has an area of 6. So we subtract 6 away from 24. And we do the same thing with the other two regions. This region right here, this has a height of 4, and this has a width of 1. So 1 times 4 is 4, times 1/2 is 2. So we subtract 2 away. So then we take this region, which is also a triangle, and find the area of this. This has a height of 8 and has a base or a width of 3. So 8 times 3 is 24. But actually, no, that's a width of 2. It can't be 3 because the entire box, this entire rectangle, has a width of 3, and we've already used up 1 here, so this should have a width of 2. So 8 times 2 is 16, times 1/2 is 8. So we take 24 minus 6 minus 2 minus 8, and we get an area of 8. So what's left over is the area of the triangle that we want. That's all of this. So that is our answer, and we're done.